Hey.
How you doing, man?
Pretty good.
How was Italy?
It was great. It was great.
Yeah?
Had a great fun. Went with the kids.
Cool.
Hot, but
Good.
very nice. Went to the seaside. Very nice.
Whereabouts?
It's near the Adriatic Sea. You know, very organized.
Cool.
Super shallow. You can walk forever in the water. You
Nice.
never get low. So for short people like me, it's perfect.
Excellent, man.
Yes, great.
So we made it. It's almost the end of the month.
Almost, but we made it.
But we
by
made
August.
it, so we're not liars.
Oh,
We
no,
do this once a month.
Made it. We make it once a month.
Excellent.
I went to talk to some more folks in the C++ team.
Okay.
The backend, but the backend of the backend, when they meet the code down to the register allocation and blah, blah.
Excellent.
So we are going to talk about vector calling convention.
What are those?
And basically it's a new way to basically call a function. And as we pass parameter to a function, we make use to as many registers as we can, you know, the YMM, the XMM, the SSC2, and so forth. So to pack even the parameter, even be faster. So
Excellent.
don't copy and don't reference extra. So you're going to learn a few things. We are going to talk with who? With the PM, Ankit, and with the dev Charles, and Kevin is the QA that tested the feature. We put them all in one office.
Good.
Very hot and sweaty. It's
Good.
going to be fun.
Good. I
I'll
love
learn
the
a few
fact that you
things.
get the triad in one room.
Yeah, that was
Very
pretty good.
important ingredients to any
Pretty
engineer.
tight.
Good.
We find a bigger room.
Cool. So before we go and meet these wonderful people, GoingNative is going to stream live.
Right.
You heard it here. We're going to stream live 3 days, all day, starting at 9 a.m. Pacific, ending at 5:30 a.m. Pacific, around then. For those of you that are actually going to come to the event, thank you.
That's going to be
I
great.
really appreciate having you in the room because I think it's going to be well worth you being there.
Yeah, we are going to be there too.
We are going to be there.
And
All
we
will
are
be
here.
there. A bunch of people will be
Yeah,
there.
we are here. So we're all going to be there.
So
It's going to be fun.
see you then, and let's go meet these people.
Yes, let's go meet the vector calling convention folks. So hello everybody. This is Ale Contenti from Channel 9. This is Gabriel here helping me in the filming because I did kind of a mess last time. Hope you didn't notice. So we are here with GoingNative, and we are here to talk with the backend people, you know, of the compiler, of the C++ compiler. And today they are here to talk about vector calling convention that I know nothing about. So we're going to learn together. That's great. So do present yourself, Ankit.
Yeah, so thanks for introducing us, Ali. Yeah, so I am actually the program manager for the backend Visual C team, which means that I'm the program manager for the compiler optimizer, the linker, and some of the tools that we make. And we're going to be talking about vector calling convention, which is a new calling convention, and it got introduced in Visual Studio 2013 preview. And
So you can download it right now.
Yeah, you can go download. You can if you have Visual Studio 2013 from the web, then you can actually go and play around with this feature.
Great. Who are your?
Yeah, and let me introduce my feature team
Yes.
here. So this is Kevin.
Hi. Yeah, I'm the QA. I work on the feature testing and also the performance testing for this feature. Yes.
And Charles.
Yeah, I'm Charles Fu. So I'm the dev of the feature and also working on the backend code generation team.
So tell us more about your stories, where you come from, how long you've been in Microsoft.
Yeah, I
How come
joined.
you like the vector calling convention?
That's a really good calling convention, as I know. So I came from California. I originally came from China. So I'm working on the California, a small company called Transmitter. It's a microprocessor company. Work on the compiler team. So like 2007, I joined Microsoft. So and working on the incubation. And
Alright.
before joining the backend team, I worked on the app. Everybody I think know
Right.
last year or 2 years ago, Microsoft have a new language extension
Yes.
called app. So I work on the app compiler team.
Sweet.
Yeah.
Nice.
So
Now even lower level.
lower level right now is the backend,
Right,
right? The
right.
code generation, x86, AMC4. Yeah.
What about you, Kevin?
Well, I also originated from China. So before I joined Microsoft in 2010.
Okay.
So at that time I work in the app team. I work as the QA. And before I joined Microsoft, I worked for Motorola for some years.
Oh, okay, cool. Nice. And you, Ankit, where are you from?
Yeah, so I guess I was
Especially, where did you buy those red glasses? Because I wonder, even if I don't wear glasses.
So the glasses are actually from an online company.
Oh, okay. Oh, the one that sends you a lot and you send them back.
Yeah, if you try out our feature,
Yes,
you get
yes.
one free. You know,
Right,
video.
right. Maybe we shouldn't advertise you, that's okay.
But essentially, I was born in India and pretty much raised everywhere. Most recently Canada. I was there for 8 years for my undergrad. And after that, I worked for IBM Research. I was a part of the Testarossa Java 7 team, so I was an optimizer developer there, or used to write optimizations for Java. And then I moved with Oracle, where I was a part of a team where I was building a new product for telecommunications space. And I've been in Microsoft now for 6-7 months, and it's been a great experience so far. Found great mentors and great people to work with. I guess that's about it.
Yeah, great. So, okay, vector calling convention, what is it? Where does it come from? Why do we want to do it? Blah, blah, blah.
Absolutely. So let's get started.
Yep.
You know, so we'll give you a bit of background about what this, you know,
Sweet.
what is the lay of the land today with respect to calling conventions, and what's the hardware state today, and why do we need this convention before we actually get into, you know, actually how it works and stuff.
Right.
So I'm going to be using the whiteboard.
Yeah.
So if you take a look at the lay of the land today, then in today's world, there's a bunch of conventions that already exist. So for the x86 platform, there's the default is cDecal, then there's fast call, then there's CLR call, and there's a few others here. And on x64, sorry,
Pascal. Pascal.
Yeah, the user have Pascal. Yeah.
yeah, that's true. And then on x64, we basically have only one convention called fast call. So vector calling convention is basically an addition to these conventions, and it's a convention that's available on both x86 and x64. It's primarily an extension of fast call.
What about ARM?
It is also
ARM, yeah, ARM actually that's a similar vector calling convention as
Okay.
well. Yeah.
yeah.
And there's only fast call as well.
Yeah.
So if you take a look at, like, as I said, like, it's an extension of Pascal, and we'll get into in the details of why it's the extension. But before we even get there, like, let me draw another table here in terms of hardware today. So if you take a look at these types, there's these types, intrinsic types that people use in their code. You know, when you're especially game programming, people use this. And if you have these types, then these basically map to vector registers. These ones here map to vector registers.
What are those M64?
Yeah, these are the intrinsics, and these are just the regular M64 types. There's a 64-bit type, 128-bit type, and 256-bit type.
Yeah.
And this will basically map today to MX registers, and this will map to XMM registers, which is 128 byte. This is what got introduced with SSC, and then with YMM registers, which got released with AVX. So these conventions that exist today don't really take advantage of the vector registers that much. And with vector calling convention, essentially, you want to leverage this piece of hardware.
Right.
So you guys are paying bucks, extra money, which you guys are not getting advantage of essentially as customers. So a great way to actually get into this a little bit further is using an example.
Right.
So we already wrote this example here. We wrote this example. You should spend time on looking at how aligned this is. It took us some time.
You can probably talk through it. So.
Yeah, absolutely. So it's a very simple example. So what you're doing is you have a structured particle, and we have two types here. We have two M128 types, X and Y, which basically are used to determine the X and Y position of the particle.
Right.
And then we basically have a function declaration here. It returns the particle type. It's called particle add. It takes in two particles, and the purpose of this function is to essentially add the X and Y coordinates of these particles and create a new particle and return that particle. So you're just doing a very simple particle add. And then there's just an main function here where you actually make a call to the particle add function.
Mm-hmm.
So the thing to notice here is you're passing these two particles here, and you're getting a particle back, and this as a result of the addition operation. So in this operation here, or in this piece of code here, essentially, when you're compiling them on x64 today, and you use fast call, this is the default calling convention. There's only one. What happens is that you can think of it as we actually make use of extra memory. So what we would do is that we will actually allocate a new temporary buffer And these pass by value arguments will they basically get exchanged with passing the address of the temporary buffer. So what you would do is you will copy the values of P1 and P2 into that temporary buffer, and then pass the address of that temporary buffer.
Right.
So not only there is stack allocation happening extra in terms of the temporary getting created, and the extra is the copy, yeah, and then there's the copy, all the instructions that come with the copy as well. So that's kind of ugly. So with the vector calling convention, the beauty of that is that you don't actually have to create the temporary. You don't have to copy over and do all the extra stuff here. All the cookie conjuring basically happens in the XMM registers. So you'll see this let me try to use a different marker. You will see this M128 mapped directly to these XMM types. So when you're passing these functions, they get passed. When you're passing these parameters, they get passed here, and there's no need for those extra stuff that's required.
And it's all part of our super smart, algorithms to allocate the registers and so on.
Yes,
So part-
yep, that's right. So basically we know which register we will allocate to which argument, right?
Or maybe we are free and we can use.
Yeah.
We only send 8.
No, there's 16
Oh,
registers XMM. On x86 you can only use 8,
Okay.
right? But x64 you can use 16.
and you do the different.
Yeah,
Depends on what your target is.
Yeah, so we decide, say, we use a 6, it's a 6 number, and also we also consider for the game application. You can see
Okay.
most have X, Y, Z,
Right.
W,
And they are actually
RGB.
Yes,
Yeah,
yes.
so we have that. Yeah.
Yeah. Well, that's very cool. And so, but you say UX, but in the end, the customer, the game programmer or whoever is writing, a simulation or needs to pass some certain time, doesn't have to do much, I guess.
Right,
The
so-
compiler takes care of most of it.
Yeah, I think being the first version of this feature in Visual Studio 2013, there is some work that you guys have to do in order to take advantage of this particular calling convention. So what you would do is you will basically decorate your function name, that's or the function definition here in this case, I guess, with underscore vector call. And when you have this, identifier, or when you're specifying this, then it tells the compiler to actually make use of the vector calling convention. So that's basically one way to enable, the user to actually, tell us that he wants to use vector calling convention.
And it's part of the manual name as well.
Yeah, that's
So
right.
you overload
Yeah, that's right.
code.
If you have the manual name, the reason I think you asked a good question. The reason we introduced the dagger name, right?
Yeah.
Vector call. So it's a backward compatible issues,
Right.
right? So you don't want their existing code compiled and the compiler change underneath to vector call, then they may have link errors, right?
And
Yeah.
Kevin tested a lot of this to make sure that backward compatible code doesn't break. Right?
Yeah. And that's the major consideration.
Yeah. I see the point.
But we also consider you just said that okay, could the compiler automatically change it under this?
Right.
Under certain conditions we do, and actually that's a really good point to simplify the programmers to change their code. Yeah,
Okay.
we'll talk that later.
Okay,
So, but this might be like the other thing that we also want to mention is I mentioned earlier that think of vector call as an extension of fast call.
Right.
And if you think about it, Charles, you can add here, but essentially fast call uses registers to pass stuff.
Of course.
Vector call does the same. It takes advantage of these
Just
extra
more
ones.
registers.
And it basically maintains backwards compatibility. So if something was getting passed by registers before, then that's also what will happen today when you're using vector call.
I see.
And do you want to add something else, Charles?
Yeah, I think backward compatible. So more registers, same register in the past, more register, and also another is stack layout.
Oh,
You have to
yes.
make the stack layout the same layout, same padding,
Yeah.
same alignment.
Yeah. It's tricky. It
Yeah.
always seems simple when you describe it like that,
Yeah.
but how long did it take to develop the feature and test it? And
It
everything
takes
for
like
now?
almost like close to like 8 months, something like that. Yeah.
So
Yeah.
great care into making sure
Yeah,
we don't break stuff and so on. Right?
that's right. Because on Windows platform, right? So Microsoft is really big company, so we have to make sure all of the application has been
Right.
working perfectly with the new vector convention.
Nice.
And I guess the other thing, just to wrap up the conversation here on how to actually use vector calling convention. So one is the keyword, you specify the keyword here. The other way is actually, we have this compiler switch called /gv. and this is a switch that you pass your compiler command line. And when you pass the switch, then what will happen is that it basically, by default, we try to return all function calls using two-use vector call.
Okay.
Other than if it's a main function, or if it's using var args, or if it's conflicting conventions already been specified, especially on x86. In those cases, we try to convert it to vector call. So I guess these are the two ways that we have right now. So if you guys want to just try out without changing your code, if you're actually going to gain anything or not from vector calling convention, one of the tricks is to just add this flag, and then you don't have to make any source line changes to your code.
Is this just a C++, or if I have the external C, is this still going to be changed to vector?
No, that's an excellent question, actually.
Yeah.
So
okay, go ahead.
you should go ahead.
Okay, yeah, that's a really good question. So we
Yeah.
have, when we change it to the calling convention to vector call, it had to be safe, right?
Right.
For any external functions, it should not be changed because you didn't have the control, or
Right.
that function has been compiled under non-vector calls.
Right.
So this is basically the GV cannot guarantee that.
Okay.
When you talk about that, at the beginning, they
Right.
kind of compiler to make sure safety. Yes, we work on the feature.
Okay.
Basically, automatically detect any external functions.
Right.
Importing function you cannot change.
I see.
Only when the compiler have the global view of all those definitions, colors, call size, we will change it.
I see.
It's under
Only
global.
when it's completely inside your things and never goes out.
That's right.
The
That
compiler always know that.
we know under global optimization, global compilation,
LTCT.
LTCT. We do that.
Whole program optimization.
Okay, so
Yeah.
you do that only under this.
Not right now. Not for. This is so. Right now, if you basically have this scenario where you're describing where an external library wasn't compiled with GV or with vector call, then we will actually crash, or the linker will actually link to it. That's not a successful build event.
That's good.
But that is some functionality that you want to add in the future, where when
That's
you
good. How you evolve. Yeah.
We already work on that one. So we will,
Okay, nice.
actually it's working right now
Yeah.
and show very good performance.
Okay,
Yeah.
good. Let's see.
Yeah.
So the beauty there would be essentially that you don't have to do any of this stuff, and the compiler will be smart enough to figure out,
To figure out.
which
That's
ones.
how we want to evolve in the future,
Yeah.
likely in the future. Great. So you mentioned that this is already available in the the preview
Yeah,
you
that's
sent out in June. I don't remember
Or
anymore.
the first preview, yeah.
The
I
first
think it's
preview.
June or
It was
late
June,
May, I can't remember.
Yeah, we sent out with the
Yeah.
Windows Blue and Windows 8.
That's correct, yeah.
Yeah. That's
So-
good. So did you already got some feedback from feature? Is it used out there?
Yeah, so we actually created a blog on the Visual C blog,
VC blog, yeah.
site, and we got some good feedback on comments on usage patterns and some of the things that we want to enhance for this particular feature.
I see.
One of the things that we heard were basically what we already talked about right now, was that to enable this automatically, for the compiler to be smart enough, or the compiler to have the brains to be able to emit
Right.
this convention
Yes.
when safe and
Yeah.
when needed.
Yeah.
So that was one. Then there's other comments on some of the design choices that we did, on why do we think this is an extension of fast call?
Right.
What is the motivation here? So that's the kind of stuff.
We'll add a link to that article also.
Absolutely,
In the chat.
yeah.
That's great. Yeah.
So one more thing that we wanted to express on is that so far we've only talked about the M64 and these intrinsic types benefiting from vector call, but this particular convention is also extensible.
Right.
So not only is it actually applicable for these types, but it is also applicable for something that's going to draw right now. So we call this concept homogeneous vector aggregate, and essentially HVA, and something like this. So this is I don't know. Let me write this example. So let's say you have something like this. So imagine now in the
It's a
same
very,
function.
very famous DX type.
Yes, very famous DX type. If you look at the math XNA library, you'll see patterns like this. And with vector calling convention, we also identify this and allocate registers for this.
Okay.
When you're passing them.
Like you were talking about the stacking and the packing and so on and so forth.
So
Yeah.
let me write this here. It's basically homogeneous vector aggregate that's what we call it. And this is also for doubles. This is just one example of it.
Right.
Like you can create another example here where HVA example 2 have a double, here, another, I don't know, A4 maybe. And you can also have like a M128 here, an array of that, and we basically use, vector edges for this as well. So it is extensible, it is not only strict, so this is a pattern, like, even if you don't use M128s in your code, if you're using floats and doubles, it doesn't have to be an array, it could have 4 floats here, like, X, Y, Z, W, for like in the 3D space you're trying to define a parameter or pixel, and even then we take advantage of microcontrollers.
That's great. And do we measure, what's the measurement? Is it fast?
Performance? Yes, it's so Kevin.
Yeah, so I work on the feature testing as well as the performance testing.
Okay.
So, so the first thing is that since this is a vector calling convention, so it's just a calling convention, it's hard to get as much as 20 or 30% performance improvement.
Right.
So I run a bunch of benchmarks. So for example, we run the DirectX mass speed up benchmark. So on this benchmark, we do get about 3% performance improvement.
Nice.
And in addition, in some scenarios, we can get about 2 times or even 3 times performance improvement.
Yeah. Just this sequence of code or certain sequences of code, and again, like, we 8 months is what we had to test this. So we're gonna try to
that's great.
bring it up. Yeah.
And with minimal invasion in the user code base.
Minimal invasion. Yeah. And in the
It's
future,
nice that you have control, in my opinion. At the beginning, it's always good to give that extra control to the customer, and they know easily, as much safe as possible, just like other optimization we do.
That's
and
right.
they're extremely safe. It's, we just do them right.
So any
benefits and
actually yes, any existing code, say suppose you don't have this vector architecture, there's no impact. Right? So it's very safe. So safety, compatibility is the first priority, like optimization with second priorities. Yeah.
Oh, that's good. Nice. Yeah.
and I think Kevin also has a video for you guys to see. We basically taken this sequence of code and added basically very lightweight UI on top of it. We call it zombie run, like temple run, and essentially.
Let's see it. Can we see it?
Yes.
And essentially.
We don't know how it come on.
Yeah, so for this one, it's just it's a demo which use the vector calling convention. Yeah. So here now is what
Super loud.
yeah. Right. So now it does not use the vector calling convention.
So those black dudes there are the zombies?
Yeah, they're supposed to be zombies. This is our initial attempt to create zombies.
Yes.
And it's actually a game. You can actually kill these guys and you get points for it right here.
Yes. So let's see what happened with the.
So that's what you do actually. That's
Yes,
why it took 8 months, because you were playing zombies all the time.
Yes, I think that's actually why it probably took 8 months.
That's
So now it's using the vector calling convention, so you can see the speed is much faster than the non-vector calling convention.
Oops. I'm gonna launch that again, I guess. I think we ran out of time. But the idea is very simple. We have a key down button here. When you press the key down key, then it basically enables vector calling convention.
So this is a vector calling convention.
So that's the number of the
That's just the
number of
no.
zombies?
That's just basically the timer. So
Yeah.
what it is basically. So right now you're not using VCC.
Okay.
Now you're using VCC.
Yeah,
So when you're using VCC, VCC comes up here.
Yeah, you can see the speed up.
Okay.
So we thought of adding frame rate and stuff, but then we thought that the difference in performance is so high that it's visually,
compelling,
compelling,
zombie around stuff.
Yes.
Yeah.
Make the game
Yes.
start.
And
Can you hit the VCC button just so I can see it?
Yeah, sure.
so here is the VCC.
Yep.
Yeah,
Oh,
so it's
sweet.
much faster. So for this case, we can get about 2 times performance improvement.
Right?
Yeah.
That's great.
Yeah. So and
And did you have to write the code in a special way, or you just
It's basically
kind of
yeah.
wrote the code
It's right
as
here.
naturally you would write, and then just turn on VCC, basically vector confirmation.
So it is a fun app. It is a micro benchmark.
Of course,
So
of
it's
course.
but having said that, like in this like essentially the code is what's here. Like we basically calculate the value, the x and y value of where the dudes or the zombies will show up,
Right.
and that's all that's happening. So we do that, with one version when the down key is not pressed, with just the vanilla version without the vector call,
Right.
and then with the vector call, and that's pretty much it.
Perfect.
That's the only change that we add with the keystroke there.
Nice.
But yeah, I think we had a lot of fun, working on this feature. We learned a lot of stuff.
Yeah.
So
That's cool.
I think we're very proud of it, and we'll see how it evolves.
Of course, that's great. Yeah, do send feedback to them.
Absolutely.
If you like it, don't like it, anything else you want to see in the in the backend, the optimization, in the link, and so on. These are the guys you want to bother, right? Faster,
These are the
more. Yes. Okay, thank you guys.
Thank you very much.
Thank you.
Yeah, nice meeting
Yeah.
you guys. Yeah.
Bye-bye.
Yeah, hope the people start to use this new common convention,
Yes.
make code faster, and to take advantage of the new hardware,
And
right?
hardware, yeah.
So next
Yes.
generation, the 512s, yeah.
Yeah, and eventually we can. That's the movies. Okay, good. Bye-bye.
Bye.
Thank you. Yeah. Bye.
Nice.
You liked it?
I liked it.
Was
Very.
good
It's
stuff.
always nice to see the great work the backend compiler people do.
Yep. I really liked it, and it's nice to understand a little bit the technology and the work that goes behind.
Sure.
And they do it in a very safe way, especially the first releases. So yeah, you liked the glasses?
I
Wear
loved
glasses?
Ankit's glasses. I like
Yes.
the red. Red's
Yeah.
a great color. Very stylish, man.
Me too. I wanted.
Certainly.
Everybody in Visual C++ gonna buy.
I could definitely pick him out of a PM lineup.
There you go.
I've been noticing that lately,
Yeah, it's
all my years at
definitely
Microsoft.
easy.
So, what about what's coming in the future? You guys gave some hints about what you might be working on.
Yeah, we'll try a little bit too, especially for this feature, for example. We talked a little bit on what we are working on, and it's about really, make it, always safe, but even more automatic, right? Without you changing even one line of code. Right now, you have to add that, little, vector call,
Sure.
hint. But when we know it's safe, we won't. You
Well,
don't have
sometime it'll be like auto vectorization.
Exactly,
which
it's
is
similar, very
unmodified
similar,
code.
very
Well,
similar.
same team.
And the same for AMP or stuff like that, right? So we definitely want to, go down, use as much meta as we can when we know it's safe. If not, you tell us and we'll use it.
Awesome. Hey, see you guys at Going Native.
GoingNative is going to be cool.
Oh, dude, it's gonna rock and roll,
See
man.
you there.
Right, we'll be live on Channel 9. Tune in. Doesn't matter where you are in
Lots
the
of
world.
big names.
Lots of big names.
I really like it.
But I think there's lots of big names that are going to be in the audience too.
Yes,
I'm
of
down
course.
with that.
Yeah, that's absolutely
Beautiful, man.
networking, man.
You got it.
Good.
Cheers.
Okay.
Boom.